A 50 kg of solution is mixed in with water via a mixer which can hold around 500 gallons. The container currently has 300 gallons of water in it. In order to balance the amount of mixture, a vent was opened, allowing 20 gallons per minute to exit the container. However, 0.005 kg of solution per gallon was still pouring in at a rate of 25 gallons per minute. Show the equation for the amount of solution inside the container. What would be the concentration of the solution as soon as it overflows? What is the amount in grams of after 30 minutes?
As you can see here, it shows that the rate going in, the influx rate would be 25 gallons per minute, while the outgoing rate would be 20 gallons per minute. So first we solve for the difference in rate, which would be R in minus R out, which is 25 gallons per minute minus 20 gallons per minute, which gives us 5 gallons per minute. Then we solve for the difference in volume, which is 500 gallons minus 300 gallons, and then we have 200 gallons. So for the first question, knowing the equation A is equal to R in minus R out, we could solve for R in by plugging in the 0.005 kilograms per gallon information and multiply it with the ingoing rate, which is 25 gallons per minute. And so we have 0.125 kilograms per minute. And for R out, it's simply plugging in A over 300 plus the rate times T. So that's A over 300 plus 5T kilograms per gallon multiplied by the outgoing rate, which is 20 gallons per minute, which gives us 20A over 300 plus 5T kilograms per minute. So the next step is we'd have to arrange all the variables in one side. So we have dA over dt is equal to 0.125 from earlier minus 20A over 300 plus 5T, which is also equal to dA over dt plus 20A over 300 plus 5T is equal to 0.125. So the next would be getting the integrating factor. So it's e raised to 20 times the integral of 1 over 300 plus 5t dt. So we substitute the 1 over 300 plus 5t with u, therefore giving us du is equal to 5 dt, or du over 5 is equal to dt. So we substitute that, and then it becomes e raised to 4 times the integral of 1 over u du, which also gives us e raised to 4 ln u, or u raised to 4. So that gives us a final answer of 300 plus 5t raised to 4. So we just plug it in with the earlier formula, which gives us a times 300 plus 5t raised to 4 is equal to 0.125 times the integral of 300 plus 5t raised to 4 dt plus c. So we use the same substitution steps as earlier, which gives us 0.125 times u raised to 5 over 5, which is the integral of u raised to 4. So by then we'd be able to solve for the constant, which is equating time 0 and relating it to the solution at time 0, which is 50 kilograms. So we'd be getting a positive 3.4425 times 10 raised to 11, which gives us the answer for the first question, the solution of the mixture with respect to time. So for the second question, first we'd have to find out the time for the tank to overflow, which is 200 gallons divided by the difference in rate, which is 5 gallons per minute, which gives us 40 minutes till overflowing. So searching for the amount of solution inside the tank at the time of it overflowing, we'd be getting an amount of 6.89 times 10 raised to 8 kilograms. And then searching for the solution, we just divide that by the maximum capacity of the tank, which is 500 gallons, and then we'd get 1.39 times 10 raised to 5 kilograms per gallon. So for the third question, we'd use the same equation as earlier, but instead we'd be using T is equal to 30 minutes instead of 40 minutes, which would give us an amount of 7.65 times 10 raised to 8 kilograms. But then the question asks for us to present it in grams, so we just have to multiply it by 1,000 grams, which would give us 7.65 times 10 raised to 11 grams.